Estimated costs concrete. My name's Barry Treleaven, and I've put together this resource mainly for our external students. They don't have the face-to-face experience that external students have or enjoy, and by this time this is released, most students would have already commenced this and perhaps even finished. This is how I have identified and estimated the concrete footings and slab. And you will find as we go through this course that I'm continually saying these first three words, which are identify and estimate. And in any costing, we need to identify what the materials are and then estimate those costs. So in this case, concrete footings and slab. Okay, so we'll look at the first slide. This is actually a CAD drawing that I did, and I've just taken a snip of it, a portion, just to show you the outline of all of the strip footing beams from plan view. And I've also included elevations on all sides to help each student understand exactly what components, what parts we're actually working on. So general terms, we normally call these footing beams or strip footings, which is more commonly used in the building industry. Next slide. Strip footings or footings beams. I've chosen to highlight each beam as I add them up, and in this instance, each of the highlighted strip footings are 10 meters and 69 long, and there's 5 of them. One of them is actually broken into 2 little sections, but that's not so big a problem. We can still see that it's pretty much effectively the same length. So in this instance, we've got all of the A's added up together, 50.345, and the two B's, 8 meters 269, and we got that length by reducing 10 meter and 69 by 1800. So overall total 66.88 times 0.3 times 0.4, which is the width and depth of the strip footing, gives us a figure of 8.02 cubic meters. Next slide. Horizontal. So I've chosen to use red here, which is a fair bit in your face, but nevertheless you can tell very easily each of the sections. And so one of the most important reasons that I put the elevations in there is so that you would actually see the distances underneath, which is really important, because when you look through here, here we have 2 meters and 50, and you've also got another 2 meters and 50 here. And so in this instance, you get the idea. We have 2, 4, 6, and I'll dot each one. So we've got 8 at 2 meters and 50, and you can see my little squiggly line underneath that. Okay, this section over here, we've got 2 meters 213, and we have 9 of them. So here they are: 1, 2, 3, 4, 5, 6, 7. Okay, so we've got 3, 6, 9. Okay, so all together, this is really important, because if we miss one of these, we can miss a substantial amount of concrete. And so there you can see it there, 9 at 2 meters 213. And in this instance, we're just doing linear meters for a start. Okay, over here we've got this small little section in between, and this calculates out at 835, and you've got 2 of them, one here and one here, 2 at 0.835. Last of all, our last one, this fellow here, and we've got 1325 from this edge to this edge, minus 300, which gives us 1 meter and 25. So total linear meters is 105.1. So 105.1 times 0.3 times 0.4 gives us 12.61 cubic meters of concrete. And at the very end of this PowerPoint, you can actually see where I put all the figures together. The other part that's really important about this is, what are these figures here? Why would I actually put those in there? If we look right up here, you can see a little detail. It's like a little chamfer. It's 45 degrees roughly, and it's where the plastic drags over the edge of the soil down into the strip footing or the footing beam, and it creates a void which is actually quite a substantial amount of concrete, quite a realistic amount. And so each of these is the perimeter. So 3,300 plus 2 meters and 50 times by 2 gives us 10.7. And so on and so forth. And so I've included all of these here, and this is our overall total right through here. And in classic the best laid plans of mice and men, I can't see my total under there because of this supermodel that's in the bottom right hand corner of your screen, but we'll find that soon enough. Okay, next page. We've actually got SF1 and SF2. So on your engineer's drawing, you've got a really good picture, and you've got a plan view, but you don't necessarily have a really good elevation. And so, for example, SF1 here is 3,500 long. There it is there. SF2, and what should actually here, we've got 4 meters 160, and then there's an extension on this. And then we've got 1,575, and so that's these three beams. Down here we've got 7 meters 240, that is face of brickwork to face of brickwork. Then you add another 300, the width of the strip footing here and the width of the strip footing there, which gives us 7,840. And you've also got one beam which actually runs from here. You can't see it, but it actually stops at this point. So that distance from there to there is 1,800. So all up, we end up with 18 meters 875. We times that by 3. We times that by 700, and we end up with 3.96 cubic meters of concrete. Next slide. Slab calculations. The easiest way to do this is to divide our slab into 3 sections. Okay, coffee time. So I've decided to actually break this down into 3 sections. Section 1, Section 2, and Section 3. So Section 1 is 15 meters long, and the dimension is actually from here right through to the outer slab here. And we've also 8 meters 269, which is the dimension from here right through down to here. Okay, so first off, we've got 12.4 square meters. Okay, we've actually worked that all out. So 1,500 by 8.2, we've actually got 12.4 cubic meters of concrete. We need to subtract this section through here. Okay, so it's 4 meters and 60 times 1.325 by 100 is 0.537 of a cubic meter, and we end up with 11.866, and so you can see it over here. Okay, there's our first section 1, that's our detail. Let's have a look at section 2, really simple one. It's actually the width of the garage, which is 5 meters, and you've got a depth here of 1,800, so 5 by 18 by 0.100 gives us 0.9 of a cubic meter. So here's section 2, there it is there. Okay, we'll just highlight underneath there. Okay, and then finally section 3. And so what you've got is 2 meters 760, and that is the slab width, and then you've got our height 1,800, so there's the formula in there, times 100, 0.496 of a cubic meter. There it is there. And so the upshot is, of course, combined total 13.262 cubic meters. Okay, and that will be going in our overall calculations. There's one thing we've forgotten here, and that is we need to reduce the step down, which is on our next slide. 150 by 150 rebate calculations. And I'm not going to go through every single one of these. I'll leave you to do that. But basically you can see here's a dimension of 15 meters. And so our first one, 15 meters times 150 by 150 is 0.337. And so on and so forth, right around the whole job. The small video that you watched in BuildSum is invaluable to actually have a look at this system, and where in corners you don't take off and external corners you do. And I'll leave you to find that out. But at the end of the day, we're going to end up with 1.21 cubic meters of concrete. That is a minus reduction. We don't need to have that concrete because we need to have that step down. Okay. The other things that we need to look at are piers, and you need to consult the beam layout plan. And I can tell you there is a slight anomaly in this plan in comparison to the plans that are in the engineers area. So just have a look at that. But the upshot is there's 26 piers at 1.2. The reason we've got beams here is because this slab is actually being built over the site of where there was formerly a dam. And so we would actually have something like this on your plan coming down, where this area is regarded as unstable. And so we need piers to actually go down. And so in the engineer's plans, the upload, I've actually put lengths there. So 1.2, 1.8, 3 meters, and then calculate the numbers. And so here we have it. There's 12 at 3 meters, there's 78.6 lineal meters of piers. So 78.6 times 450 gives us 12.5 cubic meters of concrete. Okay, so the upshot is all the vertical beams add up to 8.02. Horizontal beams work out to 13.25. The slab, 13.26, less the step down, okay, 1.215, adding the piers, and you should end up with a total somewhere around 45 cubic meters of concrete. I've got 45.81, and let's see how you go. So I hope that's been of some assistance to the external students, and gives you a bit of an idea. If you really look at these principles that we've used, working out the footing beams, working out the slab, working out the step down, they are the same principles that you'll be using over and over and over in almost a repetitious format, because our next subject, our next part that we're going to be looking at are the reinforcing rods. So think about it, that each of these that have already been calculated, the 10 meter and 69, we have 5 of those, and that is exactly how many we need for trench mesh. So you've already done the calculations, and so in estimating, we try and find ways to minimize the amount of work. It would be rather silly of us of just putting concrete over to one side, all the work we've done, and go, oh, well, I now need to go and check and make sure I got it right. Now, the reality is, this is a very stressful occupation, estimating. And so we need to make it simple for ourselves. And so if we've already worked out our lengths, then it should be quite simple to go through and work out our strip footing beams. So have a go at that once you've finished your concrete, and you will find out many of the dimensions are already here. You just have to choose the right ones. Bye for now.